Hey savvy people, it's SavvyNik here, and today I'll be reviewing some of my past episodes, expanding on a couple concepts, and taking questions about the past episodes in C++ for beginners. So this is a brand new series that I've been kind of slowly releasing, and it's taken a little while for me to get the videos going, but I finally got something going, which I'm really happy about. Now, the series is really intended for beginners, complete beginners in C++. So it's going to go over all the high-level concepts of C++, and we've started doing that. We've gone over, let's see, I guess in the last few episodes, we've discussed how to set up a compiler for C++ and any necessary tools that can help build our C++ program. We also discussed the main function and discussed hello world. And we finally, I think, talked about how to declare variables of different data types, how to assign those variables by setting them as some value. So let's go ahead and expand on some of those subjects. I see a few familiar faces from past streams. Thanks for stopping by. All right. So let's create a new file. And if you haven't already, make sure to smash that like button for me. It really does help me out. So I'm going to begin the most basic program here, which is, of course, hello world. Or actually, I won't even do hello world. What I'll do is I'll stub out main so we can go ahead and use it for testing purposes here. Xvar, thank you so much. 5K subs. Yes, we just hit that today, actually. It's quite exciting. Been looking forward to it for quite a while. Thanks again. Truly appreciate that. So what I'm going to do here is first include IOStream because I want to be able to interact with the console. So we'll need that portion of the standard library. And so we've done this in past episodes if you haven't watched already. So some of this won't make too much sense, but you know, we'll chug along either way. So int main, I'm just going to stub out our main function here. Make sure to save this. Let's see, CPP. I'm going to call it main.cpp here. And I'm going to go ahead and hit save. Of course, I'm using Visual Studio Code to work on this today. And you can use whatever you want. You can use any kind of text editor that you want. But I just like using Visual Studio Code because it's easy to install across any platform. And you can spawn off the same looking environment real quick. Spectrum, I watched some of your videos and I think you do a great, thank you so much. I really appreciate that. I'm hoping I'm getting the concepts conveyed across at a fairly easy level to understand. Hopefully that's the case, but glad you got to watch some of those videos there. So we got our main function here. So this is what really runs first in the program, and we'll be writing some stuff inside of main so we can just expand on some of those concepts that we covered before in the last few episodes. Let's go ahead and make sure that this can run. I'm just going to do a return 0 for completion, and why not just say make sure things are running so I can see stuff in the console. I'm going to see out SavvyNik. All right. And something I introduced not too long ago was this ENDL. All that is it's really short for end line, and it just creates a new line. So whenever I do this, I'm just creating a new line. There is a different way to do this. There is a there is an I guess this is called an escape sequence that we can do. This also stands for new line if you wanted, but since we're familiar with this, we'll keep it this way. Always make sure to go ahead and save, and then let's go ahead and run the program. So I like Code Runner, that extension that I explained about, or that I installed, because you can just run your code very quickly as long as it's just one file here. So one source file, my main CPP. I can just hit run code or Control Alt N, and then it runs the code, executes it, compiles it, does all the monotonous stuff for you real quick. It's really nice to have. Can I split the VS Code screen in horizontal format? Like have your C. Okay. Yeah, if that looks better, let me see if I can do that real quick. I think that's... Does that do it? No, that's just 2 columns. I don't normally do that. It's not Zen mode. I can't remember how to split it actually. That's complete. Looks like we'll just have to deal with this right now, and maybe in another video I'll go ahead and split it horizontally. I don't see it. Anyways, where was I? So we were able to successfully compile this program. We have our int main function, and it said SavvyNik, cout SavvyNik end line here. Great. So some of what we talked about in our last, well, it would have been the last, no, 2 videos ago, would have been the various different sizes of data types that we have. So what I'll do is I want to focus on the code, so I'll exit out of here. Anytime I run this, we'll run it down here. So there is a nice little way to figure out what the size of specific data types are on your system. And that's using I think it's an operator, but let's just call it a function that returns the amount of bytes. So remember we said bytes are equivalent to 8 bits in a system. So it returns the number of bytes for each data type. So let's go ahead and explore, since I kind of just went ahead and just told you how many bytes were being taken up for each individual data type. This time we're going to check and see on the system for sure what it is. So some of the data types that we talked about, the first one I'll just use, let's just use character. So we can do size of. Now notice how it's kind of showing up here in my IDE here, Visual Studio Code. It's trying to make suggestions of what's available here. So C++ keyword, they call it a keyword, I guess. We're going to use size of, and then in these print brackets here, we're going to go ahead and put in char. So that's the first data type we want. Remember, always end your statements with a semicolon. And let's go ahead and we'll run this, but right now all this is doing is getting the size and not really doing anything with it. It's not going to print it out unless we specifically say, hey, print it out to the console. And to make things pretty, I'm going to go ahead and put in end line. I almost always do this, so we'll be doing that a lot today. All right. So just to check out the chat here, Spectrum, yeah, I'd appreciate that very much if you could just leave a note in the comments. I would, I could definitely do that, split it up for you. Yeah, sorry, I don't usually use it in that form. I recently switched to Rust from CPP. I got a segmentation fault in binary search, But C++ is beautiful language. Yes, it is. Yeah, DJ likes JavaScript, but hasn't been able to convince me to make any videos on that yet. Not a huge fan of web dev. I mean, I do like web dev, but continuing on here, we're going to go ahead and run this. And what we can see here is now it says 1 here in the output. Actually, let me, I actually like using the terminal more. So we're used to doing this. G++ main, we put an output, and that output is to main, forgot the cp.cpp here, that's compiled, and then we can run main from our terminal, and we got a 1. There's just too much information on that last one. So let me see if I can clear here. Beautiful. We'll use this instead. So I got a 1. So what does 1 represent? Well, 1 actually represents a byte. And just to clean things up, I'll add byte here. And let's rerun this. All right. That way we know what our unit is. So 1 byte, the size of a character is 1 byte in this system. So this is important to understand because this gives you information about what a byte can store. So a byte of data, again, is 8 bits. Let's bring up a calculator. And actually, while I'm bringing up that calculator here on the screen, let me see if I can get a little bit of music going. Helps me out a little bit. Let me know if it's too distracting. I'll go ahead and end it if it is. So in order to find out at least how many decimals we can store in a byte, we should be able to do 2 to the 8th power. So this will tell us how many different basically numbers can be stored in a byte. So if we do 2 exponent 8 and we press enter, that gives us 256 numbers. So what's the significance here? Well, this helps us, at least for some of the other numbers, tell us what our limits are for those for that data type. So you can't just go infinitely and type in any number you want. Where this is going to be apparent is more of in, let's say, an integer or a float or a double, and we'll check those out in a little bit here. And before we do, though, I'd like to go ahead and talk about how characters are actually represented in a system here. So there's actually something called an ASCII chart that can help us out here, and I'll pull that up as well. Because if characters are represented by, let's say, a number in the system, well, there must be something in the system that translates that number to an actual character. So if we say that you can go between, let's say 0 and 256, but since this is actually a signed number, meaning you can have negative and positive numbers, you have to divide this by 2. So technically we have 128 positive positions that we can fill, but we have to include 0. So technically you're going from 0, and that's counted as a number, to 127. So with this in mind, if we bring this up, now we can see how the ASCII chart relates over to this number for characters. All right, so if we look, let's pay attention mainly to the decimal here, this column. So we can see the various different, so we have decimal here, decimal here, decimal here, and decimal here. So these are all the characters that actually get produced by the character data type. right here. So we have symbols, numbers, some more symbols, capital letters, lowercase letters, and then some special non-printable characters here that kind of help you interact with either the system or the console. So we can see that if we typed in a decimal 0, that would give us this null character. If we typed in a decimal 32 as a character, that would give us a space. If we typed in, let's say, decimal 97, we'd get a character lowercase a. So it's interesting to understand how a character is related to a hexadecimal format or a decimal format. That way you kind of understand that you can actually use numbers to represent characters like in the alphabet. All right, so just to go to the chat, SavvyNik use Clang. Will there be any videos on pointers and smart pointer new operator? Yes, there will be videos on that. That's, going to be quite far in the future, but we'll get there. Have I ever tried Tail OS? No, I have not. Asks, is there support for Unicode characters in C++? You know what? Off the top of my head, I don't know, but we could always look it up. I think there is. You might have to... Yeah, there definitely is. Just not something I use. So let's keep continuing here. So we went ahead and figured out that a character has 1 byte inside of it. What does a integer have? Probably should have just went ahead and copied that, but no big deal. Let's rerun this, or better yet, I'll go back to terminal, make sure I compile my program, rerun it, and then we have 1 byte for a character, 4 bytes for an integer. So as we talked about before, let's run our calculator real quick. And now we know that there's 4 bytes, which is equivalent to 4 times 8, 32 bits. So if we do 2 to the 32nd here, we'll get some crazy number. Oh, let's see, maybe in the billions, 4 billion something. So basically what this is telling us is that a 4-byte integer can support up to this number. Now this is true for an unsigned, meaning only positive number integer. But if we're using signed integers, which we are in this case, that's what it's defaulting to, we have to divide this by 2 and subtract 1. And that means we can go from negative and positive this number, and then the positive side of this is going to be 1 less because we have to include 0 in those. So that's basically the numbers that an integer can represent. It can represent up to this number, or negative, positive to this number. So let's write that out actually if we can. So it's going to be something like this. Negative to, let's just do 2, and then that, because we have 0 to this. So we go from this number all the way until we get to 0, and from 0 to this number is what can be represented by an int. And we can simply find that out through the calculator like I did there in the last method. It's something just neat to know about. Not like you'll be using this a bunch. The place where you'd want to be able to know this type of information is when you're getting very close to this number. What happens when you do get to this number? Well, we can see what happens actually. So let's go ahead and then talk about that next. Thanks for stopping by today, if you are. Make sure to smash that like button for me. I do see a few familiar faces, and if you have any questions as we're going along through here, please make sure to go ahead and type them in the chat. What I want to do now is kind of play with Rollover real quick, just to show you what would happen if I had this number. So we talked about assigning values to data types. So let's just do int test, and let's set that equal to a number. Okay. Don't need this here, or actually, what I'll do is comment that out. Rerun. Great. Let me print out test. Of course, include my end line. Why am I doing this? Well, I'm trying to see what pops out here. So we got no warnings, and we printed out a number of an integer, and that number that we set it to is the maximum number for an integer, at least on this system since it supports 4 bytes. Well, let's go ahead and add one more to this number up here. Just add 1. What happens at this point? Does anyone know what will happen? If you do know what's going to happen, go ahead and post it in the chat, and let's see if you're right or wrong. So I'm going to make sure to save that, compile things, run, and look at that. We got a negative number now, which is very interesting because that negative number matches this number right here that I wrote out as the most negative number that we can save in a signed integer. Well, the reason being is what happened is things rolled over. They went, basically you have, let's imagine 32 bits. So I'm just going to put a bunch of zeros here. Let's imagine this is like 32 bits here. And once everything finally turned to 1, or sorry, it would be something like this. The very first number would be 0. So this bit would represent a positive or negative, and let's just pretend there's 31 other bits behind. Well, once all this changed over, what would have happened is this would have became 1 and all zeros behind it, and that would have made this number negative. So it starts from the bottom and works its way back up. So it's a very interesting phenomenon to know about. If you try putting in a value that's too large, it's going to roll over and put you back into, well, some negative number here, at least with an integer. Anyways, now that we kind of know that, let's continue on with, let's get the size of a float. And then talk about a float. So a float is also 4 bytes. And we'll talk about the limits of all of these again later, so we can go ahead and verify the math. So a float here, again, is 4 bytes. So Does anyone know what a double would be? So if a float is 4 bytes, what would you expect a double to be? C# or C++, what would you prefer? So honestly, I've always used C++. I don't have much mention on C#, to be honest. C#, I believe, has to deal with the .NET framework from Microsoft, and it kind of adds a layer of complexity there because it has to work through a framework before you actually, really just control stuff on the system. So that it depends on the type of program you're writing, whether or not that type of overhead will cost you anything. So it's always something to think about when you use languages that are based around specific frameworks. All right, so we said that a float is 4 bytes, and we're going to guess what a double is. So a double is going to be, let's make sure we compile, run 8 bytes. Or really, it's just 2 times what a float is. So if a float is 4 bytes on your system, then it's going to be 8 bytes. If it was 8 bytes for some reason on your system, it'd be 16 bytes as a double. That's why it's really called a double. It's just two floats. Think of it as 2 floats. And it just allows you to have larger numbers. That's all. Larger decimal numbers, I think the same amount of precision. All right, so now we know what the size of a character is, integer is, float, and double on at least my system here. What else did I want to do with this? Let's see. Oh, yes. The one thing I did mention in one of my videos was there is another data type, a basic data type called a void, which is a valueless number. Really, it's just valueless. There's nothing to it. There is no value. So the interesting part of this is if something has no value, does it have any... does it require any memory storage from the system? And if it does, what is it? So we can answer that question using size of void. Let's see if it'll return something. I'm actually interested. I don't know if I've ever tried this. All right. So we do get a warning. But that doesn't mean we failed here. It says 1 byte, which is interesting. Let's try this again. Oh. Eight bytes. Very interesting. So, not trying to trick anyone, but I did 2 things. I did a basic void here, and I think the system actually went ahead and said that it can't actually return the size of, here it's warning us, it cannot return the size of the void type. That's because I'm pretty sure void doesn't actually take any space up since it's valueless. But if we did void star, which is actually a pointer to void, that does take up some space, and we did see that took up, let's see, 8 bytes. Reason being, it's taking up the size of a pointer, so we'll talk about pointers in the future. It was just something interesting to look at and understand. So we got a hardware question. I'm thinking of buying a new laptop, and I'm currently based on Wayland. Love it. And well, NVIDIA doesn't give a dang about Wayland. Sorry, character limit exceeded. So what laptop should I get? I don't see any. Not even System 76 giving the option to use Radeon GPUs. I'd love some high-end laptop that run Wayland flawlessly. I don't know specifically what manufacturers are going to well, supply AMD graphics off of the top of my head. Some of the laptops that I really like are the Dell XPS. They're a great workstation, especially if you're doing development and stuff like that. It's a very nice computer. I suggest always going for at least 15 inches on the screen. I like having a lot of screen real estate. And then, yes, as DJ, my second suggestion would be a ThinkPad. Both, I think, have fairly good... so they have fairly good Linux support, and I do like the those two brands. So those are my suggestions there. But I don't know. I don't know something specific to tell you. Maybe we can talk about that later. And if you're new and stopping by today to watch this stream, make sure to go ahead and subscribe below. Hit the notification bell to follow this series. I'm going to try and do one of these kind of reviews once a week. And if I get to it, great. If not, you'll have the episodes to follow. All right. So, of course, if you have any questions, feel free to go ahead and post them in the chat. Don't be shy. If I can't answer them, I'll just let you know I can't. All right. So, the next thing I kind of want to go over here is how to go ahead and verify the limits that I mentioned before. So we said, you know, there's these sizes here that we can check, and that'll tell us how many bytes each of these take up on the system. But how do we actually see what the lowest number and what the highest number some of these data types will accept? So there is a way to check this out here. Now this is going to look a little convoluted. Don't get caught up on the syntax here. Let's just be aware that this exists and we can use it. Because if you wanted to troubleshoot some things, this is a good way to figure things out, at least for your whatever system you're using. So again, I'm going to go ahead and use cout. That's going to print something out to my console. I'm going to use something called Numeric Limits. Let's hope it exists here. So let's just do int first. Then I'm going to look for min. And let's try printing that out. So this is going to be minimum number for an int. See if we can get something out of this. So nothing too special here. It's just we're printing something out, then we're putting our own few characters here all together. This is known as a string, and then we're also including this function min and allowing it to return the minimum of a templated int, and then we put a new line character at the end. Let's go ahead and run this. I'll just run it like this. All right. Probably messed that up. Maybe numeric limits is not available. Oh no. Let me make sure I got this right. Cout numeric underscore limits integer min and line. I don't think I had to include anything. I would have thought this was with the system, but we might not be able to do this, which then the first method would have been better to know, which we already covered, but yeah, was not declared in the scope. I thought this belonged to the standard library, but I must be wrong. Let me look up numeric limits real quick. You know, it might be in a different header class. Let's see if it's limits. Maybe that's what I have wrong. Rerun this. All right, that's it. So there was a different header it actually belonged in. So it is part of the standard library. It just, I didn't include the proper header from the standard library. As soon as I included limits, it did let me compile. So let's go and check this out here. I'm gonna recompile, hit main, and now I see this number. So what does that number represent? Well, we actually figured out this number before. This is the minimum value that an integer can represent or hold or get assigned with. So now you know the minimum number. So we'll just say, again here, this is for int min value. All right, so now we know the int minimum value. I'll put a space here, and why not a colon and another space. And we can now reuse this to figure out all of our other minimums. Let's talk about that. Actually, before we do that, why not figure out what the maximum is? Is this going to match that number that we calculated earlier? Well, we'll be able to tell here in just a moment. So the number we calculated as our theoretical maximum is actually this number here. So I'm going to write this out, and let's go ahead and rerun this. So all I did here was change min to max, and now I should be able to rerun and recompile first. And look at that. Does this number match this number? Sure looks like it. We should have changed this to max. But this is a great way to check the limits of any given data type. So if you don't know what the limit is, you know, you can't work out the math. You can't use the calculator, you can't work out the math, or it just doesn't make sense to do it that way. There is a built-in way to do it if you include limits and you use this right here. I'm not going to go into too much depth with what all this means, but just understand all you really need to change is you specify the data type here between these symbols here, the less than and greater than symbol, and then you define whether you want the max or the minimum. Hopefully everyone's following along still. Thanks so much for stopping by today. We'll continue on here. Let me just get a little background noise going. So we talked about the character size as well. But before we get there, let's check out floats. And we'll check out what the difference between a float and a double is as far as the minimum and maximum sizes. So I'm going to go ahead and copy that. So this is for, let's do a float. If you have any Linux and or programming questions, make sure to go ahead and post them in the chat. I'll try responding to them. So now we are looking to see what the minimum value of a float is and what the maximum value of a float is. So again, important to know in case you're getting up somewhere in a really large number and you don't know whether you can represent it with the float. This is a good way to check. Let's go ahead and compile and run. And now we can see that the float minimum value is this very large number. So this is 1.17 times 10 to the negative 38th power. That is a huge number. So you can represent a lot of numbers here. Also notice that there are decimals here. So a float is a decimal number. So What kind of maximum can it support? Well, it says 3.4 times 10 to the 38th power. Amazing. MK, yeah. 40 minutes have passed since the start. I thought only 10 minutes have passed. Well, hopefully I'm not boring you. There's just a lot to go through. A lot of interesting stuff. So now we understand what a float can store at its minimum and at its maximum. And we'll continue on to a double. So if anyone can in the chat answer what they think, do you think if we do a double, is it going to represent 2 times this amount or not? Let's check. I'm going to say no. I'm going to say it's going to support well over 2 times the amount, but let's check. So all I did was just change this double here inside the less than and greater than symbol for min and max. That's all I need to do. Recompile. And here we go. Now notice we have 2.2 times 10 to the negative 308th power. That's amazing. That's a very, very large number. So if you're dealing with numbers larger than this, you're getting close to infinity. But of course it's there. Well, I'm really happy for you, MK. That's great. I'm glad you're enjoying the series. Hopefully it's helping people out. So we talked about a float, a double, an integer. Let's finally talk about the character. So the character is a little special here because, let's see, I bet you we get something a little goofy when we do a character, and we'll fix that goofiness. So let's do char. We'll do min and max for that, and just to keep things clean. I'm going to go ahead and put char in front. I'm going to recompile, run this, and look at that. Isn't that interesting? So it says char min value, question mark. Char max value, nothing. Well, that's because it's actually returning some sort of non-printable character from here. We can fix this. We can actually do a little bit of a cast here. And if I do int, and then I surround my numeric limits inside of it, I think we'll get the right numbers then. So let's go ahead and give that a shot. So I mentioned before, really the numbers were, let's see. Well, let's just come up with it one more time and see if we're right. So my guess here is going to be 2 to the 8th power because we know a character takes up 1 byte. So that's 256. But I have to divide that by 2, so I got 128. All right, so my guess here for the min is going to be negative 127. Or actually, 128. Let me get the calculator back up. Yes, and then negative or positive 127 here. So let me try rerunning this. And do these match up to what I guess? They sure do. So the reason being is the character is currently a signed value, meaning it contains both negatives and positives. And all these numbers represent is some type of a character. Don't get caught up on that this is showing a number right now. Just be aware that these numbers just represent characters. That's it. And we can figure out those characters through just Google something, and it's called the ASCII. Just look up like ASCII C++ table, something like that. Any ASCII table will work, but it's just something to keep in mind. Of course, if you're new, you're stopping in, you're wondering what we're talking about, we're actually reviewing the C++ tutorial for beginners series that I have, and I'll go ahead and let's see if I can link and share the playlist. Here it is. So if you want to go ahead and learn C++ concepts and of course follow along with these reviews, make sure to go ahead and watch that playlist, save it. I try coming out with a couple videos every week. We're going to be covering quite a bit of information using those, and I hope to help beginners understand how to begin programming with C++ and learning the concepts of C++. So I believe you can also do this with the numeric limits. Instead of, let's guess a different number here. I'm going to go 0 to 255 here, and I'm going to do an unsigned, meaning there's no negative numbers allowed. We can also use this, and I'll go ahead and talk about this in a moment because we haven't really seen that yet. So look at that. What was my guess? 0 and 255. So the minimum value is 0 here for an unsigned character, and the maximum value is 255. And if we look up here, if you were to add these two numbers together, right? If this wasn't a negative, you'd get 255. So the representation goes from negative 128 to 127. Instead, when you use an unsigned, it goes from only positive numbers, 0 to 255 here for a character. So this works across the board. So for an integer, we could do it as well. Let me go ahead and, since we got a lot going on here, I'll make another file here. So there's nothing special about calling this main. We can call it whatever we want. So let me see, let's call it signed CPP. Just going to paste this back in, and we'll go ahead and reuse some of this. So I'm just going to cut it down to about there. So let's check out so there's really, let's talk about this first. So there are a few more options available here for data types. We have unsigned data types and then signed data types. So if you know you're going to represent a positive value and you don't need negatives, and you might need more room to go ahead and store that number, maybe it's a very big number. Let's say it's an integer and it surpasses that 2 billion whatever number that we calculated earlier. Well, you might want to use an unsigned number, which allows you to use even more numbers as an integer, because you no longer have positive and negatives. They only become positives. So let me show you what that kind of looks like. First, what does an unsigned integer look like? And how many bytes does it take up? And then what does a signed int look like? How much does it take up? And finally, let's say, we'll go ahead and copy this. Save that, and we should be able to use unsigned in here. So let's check out what an unsigned integer looks like so we can really drive it home as far as what unsigned looks like versus signed here. All right, so let's just run. All right. So we say an unsigned integer takes up 4 bytes, and so does a signed integer. And it says unsigned, did I do something wrong? Maybe you can't do min and maxes with unsigned numbers. Seems weird, so let me see if we can. Unsigned int. Oh, that's because I'm casting it as an int. Let me remove this. We must have been using this as a character before, and I'll rerun. All right, so here we say 4 bytes for both an unsigned and a signed. And let's do a comparison between these two. So I'll erase this, and let's see what the limits of a signed number look like. And I think this will look very familiar to something that we had before. All right, here we go. So first off, it says a unsigned integer is 4 bytes in length. So a signed integer is also 4 bytes in length, but they can represent different values. And that's because of the key word that we talked about, signed versus unsigned. So a signed value allows you to go between negative, right? Negative 2 billion whatever, to positive 2 billion whatever. But a unsigned integer, min and max, has somewhere, actually allows 2 times more numbers in the positive realm. So from 0 to 4 billion, let's say 3 billion almost. So it's important to know that unsigned and signed exists if you need to use very large numbers and you don't know how to store them. Well, this is a good way to do that in order to store only a positive value. So I got a question from MK. How long will the series be? So I don't know exactly, but I imagine having over 100 videos on the series. Because there are so many topics to cover in C and C++. With this review, it's technically already the 5th video, and things that we've covered are data types, and how to declare them, how to assign those variables that have certain data types. We've also covered the Hello World program, how that runs, how it works. We've set up an environment, and what else did we do? I think that's about it. We did something like that. Anyways, going off memory here, there's quite a bit to cover because C++ is such an all-encompassing general purpose language, and there's very many concepts to it, and it takes quite a bit to understand all the concepts. So it'll be very long. But we take it in little steps, and then we get a really good understanding by the end of things. So that's my plan, at least as of now. If things change, of course, I'll let you know. So we have, let me ask this question, if anyone in chat wants to answer. Does it make any sense for me to go ahead and post the code for these reviews after the fact, maybe on my GitHub page, so you can kind of look through what was kind of covered or what we did? That way you can play around with it by yourself, or does that not sound, that doesn't sound interesting? Let me know. All right, let me check what else to cover here. I think I got through most of the stuff that I wanted. So we really talked about the various different sizes of data types using size of. And then we also talked about the limits or constraints of certain data types using numeric limits here. And then we also discussed how characters are encoded in the system. And we can, again, reference the ASCII table in order to understand, you know, here's a more simpler ASCII table, and it'll show you kind of, honestly, I think this is better than the last one I looked at. So looking at this, we can see, you know, there's a decimal representation of each of these characters. There's also a hexadecimal representation of all of these characters. So maybe, I think in the next review, what I'll do is try and print out the printable characters inside of the console, so we can see, you know, what's actually available in our system, and does it actually match what this ASCII table is telling us. I think that'd be a nice thing to do. I think I'm running out of time for today to do it in this stream, but I think that'd be kind of fun in the next one. MK says, please upload the code. All right, yeah, if it's going to help anyone, I'll go ahead and try. I'll probably call it, I'll have individual files, and I'll just call them whatever I was using, I don't know, whatever functions or whatever point I was trying to get across as far as the CPP name, and then I'll go ahead and put it in its own folder in the repository, and I'll keep them all together probably. Now, I don't know that they'll all be running code, but I'll try my best to do that for you. So if anyone else has some questions for me at this point, or would like to review anything that I've covered in this video, please let me know in the chat. While you're doing that, I will be right back. All right, and I'm back. I don't see any questions. So I'm going to go ahead and wrap up the stream here. Thanks for everyone who stopped by today. I appreciate you stopping in and supporting the stream as well as the channel. If you have any questions, comments, or suggestions, please make sure to post them in the comments section below. Also, make sure to subscribe for future videos and make sure to like the video. Catch me in a great community on Discord, and I'll catch you in another stream. Thanks so much for stopping by.